Here's a quick description of homework set number 3 for ECE 376. Now the homework problems change every semester, but they'll be kind of similar. As a reminder, to get to homework set number 3, go to Bison Academy, the semi-official website for ECE 376, takes you to the syllabus, and we're right now on week number 3, homework 3. Now the first problem is solder your pickboard. You should have a working pickboard by this week because the last problem is trying to get it working, or demonstrate your code. If you can't get your board working, just come see me. I can usually get it fixed in a couple minutes. Otherwise, I got boards I can swap out with you. But you do need a working pickboard. Makes the class a whole lot more fun. The first problem after that is come up with a circuit that outputs a binary signal 0 volts, 5 volts. A PIC microcontroller is a binary device for binary inputs. The input, like on port B pin 0, needs to be either logic 1, logic 0, 0 volts, 5 volts. So convert temperature to that. The first one is one a device that has a output like this. When the temperature is above 35 degrees Celsius, output 5 volts. When it's below 35 degrees Celsius, output 0 volts. To do that, you'll need to use a comparator. On problem 2, I add hysteresis. So now it looks kind of like this. I turn on at 40 degrees. I turn off at 35. That's a different circuit. That's a Schmidt trigger. So design a Schmidt trigger so that the output is your 0 volts, 5 volts. That way the PIC can read temperature. Problem 3 is looking at LEDs. Come up with a circuit that lets a PIC drive an LED at 15 milliamps fixed. In two different courses, electronics and embedded, there's kind of a different way of doing colors. This would be like 1 pixel on a scoreboard. If I vary the current, I change the contribution of red, green, blue, get different colors. One way to do that is hardware. That's what you do in electronics. Vary the hardware, I can vary the current. In this course, I changed it using software. In software, I can vary the duty cycle. If I'm 80% on, I'm 80% of the current. 100% current is defined as 15 milliamps. Come up with a circuit that outputs 15 milliamps to an LED, to 3 LEDs. Problem 4 is, instead of doing these nice small LEDs that need 20 milliamps, do a bigger LED, a 3-watt LED that needs 1000 milliamps. The problem with this is a PIC cannot output 1000 milliamps. You need a buffer circuit. That'll be a transistor. Use a transistor as a switch to turn on and off an LED. When the PIC outputs 5 volts, the LED is on. At 0 volts, the LED is off. Problem 6 is timing. Write a program that outputs a square wave. So what I need to do is wait n clocks. So I'm just going to toggle a pin every n clocks. If I do that, I get a square wave out. I want n to be such that it's 116.51 Hertz, which is the delay routine. Write a delay routine where I toggle, wait, toggle, wait. If the wait corresponds to 116.51 Hertz, or n is actually 10 million over 2 times Hertz, come up with that wait loop, I should get 116 Hertz. If you go on your cell phone, called Piano Tuner. This is a nice way to measure frequencies. Just output the signal to a square wave, and it'll tell you the frequency. So like if I whistle, okay, not very good at whistling. It'll tell me the frequency of that square wave. The last part, it varies each semester. For this semester, it's do something like build an RGB flashlight. What I want are the requirements. I want to push a button, and that changes which LED is turned on. First part is give me a flowchart for a program that does this. Presumably in terms of hardware, that'll be like this problem. I'm driving my 3 LEDs with 3 output pins, call it RC0, RC1, RC2, for example. Come up with a program that determines which lights are turned on, white is all 3 are turned on, which lights are turned on when I hit a button. Plus, if I don't push a button for 10 seconds, the light automatically turn off. Problem 8 is write the assembly code. Number 9 is test your code, meaning collect some data. Verify that when I hit RB1, the red light is on, 2, the green light is on, and so on. Verify when I don't hit a button, 10 seconds later it turns off. And finally, demo. You can demo in person or with a video. So that is homework set number 3.